Fall protection. Per OSHA guidelines, fall protection must be worn anytime when working over 6 feet. Fall protection is defined as a backup system that is put into place to support a worker who could lose their balance at height while on a job site. To work safely, fall protection must be inspected prior to each use, meaning if you remove the personal fall arrest system, or PFAS, for any reason, that it must be inspected again for damages or defects once you return to your working area. This includes lunch breaks or any other task that may take you away from your project. Fall protection must be worn in accordance with the manufacturer's recommendations.
So we're going to talk about fall protection. One of the key items, obviously, anchor point when we do the ABCs of fall protection. Whenever looking at your anchor point, the first thing you want to do is identify some place to put it, whether it be a JHA, THA, your task hazard analysis. You'll identify that location for your anchor ahead of time. When in the field and using that anchor, you have to keep in mind 5,000 pounds per person. The visual you use in the field is, would that anchor I'm about to attach to, that structural element, support a full-size pickup? And if the answer is no, or I don't know, you need to call a timeout, contact your local safety person on site, and look for better places to tie off. Once you've identified that appropriate location, you have different options for anchorage connection. Most commonly, a tie-off strap, a beam strap. What you'll hear this thing referred to on occasion as a choker, but please do not misconstrue this as a choker for lifting and slinging equipment, pipes, rebar, things like that. This is just for people. This is your protection device. You'll notice there's a small ring and a big ring. It's a pass-through adapter, so the small ring passes through. Prior to use on all this equipment, you're going to do a quick inspection. I'm going to make sure my tags are present and legible. I'm checking all my webbing. I'm looking at all my stitching, all my metal components, making sure there's no rust, no cracks, no bends, things of that nature. If at any point I identify stitches missing, tears, burns, UV degradation, I'm going to take this out of service. When you take it out of service, either turn it back into the safety manager, or if you're doing it on site, cut it up, cut the D-rings off so nobody else can use it. Once I've approved this piece of equipment and it's good for go, again, pass-through adapter. I'm going to wrap it around the structural element. If I have to tighten it up, and I can, I want to wrap it as many times around that element as possible, get that last pass through. If I'm wrapping it around a beam and I can't get it around a second time, I'm going to leave it hang as tight as I can. This will become my tie-off point that I calculate my fall clearance from. Initially, you'll find that element. You may say that beam is 20 feet up in the air, but now it's going to be 19 feet down to my tie-off point. Again, if I can wrap it around, I want to do that. I have seen these where if you pass it, it doesn't quite pass, but I can get my hook in. Don't do that. It has to be a complete free clear. It's going to be one hook to one anchor, and you're never going to have a hook into two. It's always 1-to-1 ratio when using these types of devices. Occasionally, you'll go on a job site. A general contractor has provided a cast-in-place strap. You'll see this element hanging out of a ceiling, a column, things of that nature. Same process. Make sure the webbing's good, tag is present, metal's good. If any of this looks questionable, red tag it, let the general contractor know, and don't use it until further notice. Other options, gliding beam anchors. This attaches to an I-beam element, things of that nature. Glides along with me. Whenever I set these elements, and the reason there are so many options, for example, existing concrete, I can drill a hole and use this. The reason we have so many options, I need to have that anchor point as close to overhead as possible. A lot of times people will set an anchor place, walk off 20 feet away from it, and they're only a story up in the air. There's too much swing fall, there's too much radius on that. Whenever you set that, you want to think about 30 total degrees or 15 on each side. So from the center point of this table, if this was my anchor strap, I'm basically going to be my arm's reach on either side of this thing is my fingertips from that point. If I have to get beyond that, I'm going to move that anchor point down, whether it be an overhead gliding beam anchor that stays with me as I work, or whether I have additional anchors like this and a double lanyard that I can clip as I go. So keep that anchor point as directly overhead as possible at all times. Once we've selected our anchor point, next step will be body harness. Same as with the anchor, you want to do inspection prior to each use. You'll hear often each day. Really, it's prior to each use. If I use this harness in the morning, take it off, go to lunch, when I come back, I want to re-inspect it. Every time I don this harness, I want to inspect it, look for damage that could have occurred during the process that morning. My inspection process will be to check my webbing. I'm looking at my stitching. I'm looking again for burns, cuts, UV degradation. On the leg straps, there's a subpelvic strap. There's a crisscross pattern. This holds the subpelvic strap in place. When I fall, I end up in a seated position. This strap will help cradle that load, keep the force from hitting my legs full throttle. In your legs, you have femoral arteries that can sustain a lot of damage if this initial fall hits those. Again, this strap helps distribute that load, cradle that fall, so I end up in that seated position distributed. On the back, there's a folded area with a stitch. You'll also see a small tag sticking out here. In the event of a fall, this stitch will actually pop. That's my fall indicator, and you'll actually see a do not use tag become exposed. If I have padding, I do want to unsnap this stuff and look underneath here from time to time, make sure that there's nothing trapped in there wearing and abrading that harness. Make sure, again, my metal components, D-rings, are not bent, cracked, any sort of rust. Pass-through adapters, my adjusters. On your leg straps, all of these should have finished ends. Sometimes people use this hook, they think it's okay to cut it. Never cut or modify a harness. You want to make sure it has a finished end. Even though there's additional material you may not use, I'll show you how to store that when in use. Check these grommets, make sure they're tight, that there's no sunlight showing through there, and they're all intact. If any of these things are loose, stitches missing, grommets missing, take it out of service. Again, the process on taking something out of service is either turn it back into the safety manager, or if you're told to in the field, cut it up. When you cut it up in the field, cut the D-rings off and dispose of it. If you do not cut it up, it will end up on somebody else's job site. Once I have my harness inspected, I want to make sure I allocate the tag. Again, tags are present and legible. And I'm going to note that I have inspected this harness. Harnesses will, depending on company policies, sometimes will have a 5-year life, but depending on the policy, you can extend that beyond that if you take care of it. You guys in the field, as you get dirty with this stuff, it is okay to wash them. Mild soap and water, hose it off, hang it to dry, it'll last longer. Once I have it inspected, I know it's good, it's proper to use. I will don my harness. Make sure you take everything out of your pockets. That includes keys, cell phones, knives, things of that nature. Anything that's under this harness when I fall will get pressed against my body. This is a 5-point harness, so I have chest straps, leg straps, and torso adjustment. I want to get my initial set. The torso adjustment is most commonly where we see the misadjustment. There's a lot of different material that can be here, and sometimes people leave this loose. If I leave the torso misadjusted to where I have a lot of slack, my leg straps can migrate down. If they're not snug and I fall, they will head north at a rapid rate, and you can do a lot of damage to yourself. We call it huevos adios on the job sites. It will do a lot of damage. We have safety bulletins that revolve around that. You have to have these snug. Now, when I talk to guys about making sure it's snug, they hear that, they tighten it up, and they walk around with this thing so tight they can't move. You still have to be able to lift your legs, climb ladders, bend down, pick up equipment. The way we do that, 2 fingers in flat on the leg strap is sufficient space. If I can get more through there, it's too loose. If I can't even get my fingers in, it's too tight. I talk about that additional material. As you can see, I've got a lot of stuff here, so this could become a hazard. Your harness is equipped with a keeper on each side to store that additional material. This also has a keeper to store that extra torso equipment here. It's got a double loop on it, so I can store that out of the way for safekeeping. I want to make sure I have all that stuff tucked out of the way when I do when I'm climbing. All this extra material could become, again, it could become a catch hazard if I'm walking by equipment. So this is proper, this is inaccurate. My chest strap should be right at my sternum. If it's too high and I fall, it could choke me out because I will shrink into this harness when I fall. If it's too low, my shoulder straps could open up and I could pitch forward and change the entire dynamic of that fall. Again, that subpelvic strap's beneath my tailbone, so when I fall, it'll catch and cradle that load. My D-ring is up between my shoulder blades. If my harness is not adjusted properly, that D-ring can slide down towards the middle of my back, which will create a pendulum effect again. When I fall, I want that D-ring going straight overhead to absorb that energy properly. You'll notice this harness has side D-rings, shoulder D-rings, a back D-ring. The only D-ring you're going to attach your fall arresting device to will be that back D-ring. This is my fall arrest anchor point with my harness. Shoulder D-rings will be used for extraction, for instance, in confined space. Side D-rings are just for positioning. So your only point to connect your fall arrest device will be that back D-ring. So once we've selected our anchor point, we've donned our body harness, everything is in check, we've identified our location to tie off, the next step will be C as your connector. Most commonly in the field, you'll see a 6-foot fall arrest lanyard. The reason you guys are using these mini retractables is clearance. Whenever I look at that anchor point, I have to figure out how far from the anchor point to the ground will I need. With a 6-foot standard lanyard, I actually need 18.5 feet of total clearance. When I fall, this lanyard is going to go 6 total feet. I'm 6 feet, and you'll notice the D-ring is between my shoulder blades, but in the event of a fall, I will have what they call harness shrink. I'm going to shrink into this harness. That D-ring will be even with my height. So again, calculating, I'll have full length of lanyard, height of the worker, plus this shock pack is designed to open up and deploy to absorb that energy. When you take that fall, it'll absorb the energy to keep you from having a force against your body, and that little shock pack will open up, such as this one, and that material will stretch to absorb, doesn't stretch it, it tears very succinctly to absorb that energy. So I have a 6-foot free fall, 6-foot height of the worker, up to 3.5 feet deployment of this shock pack, and we usually build in a 2 or 3 foot safety factor. So you can see there's a lot of clearance needed with a standard 6-foot lanyard. That is why we've gone to these small devices. When these fall, they act like a seatbelt with an airbag. If I slip and fall, I have immediate lockup. I reduce that entire 6-foot free fall swing that I would have originally had. Again, back to anchor, that's also why it's important not to be 30, 40, 50 degrees away from this thing. I need to stay 15 on each side, so if I do fall, it locks and I don't have a massive swing radius. So make sure you keep your anchorage and your body harness between this connector within that swing radius. Again, if I'm stretched out, if I'm 2 feet away from it and it locks, if I'm 3 feet, it locks, if I'm 2 inches, it locks. No matter where I am in this device, when I slip, my lockup is the same. Again, I still have that energy absorber that could deploy up to 3.5 feet. Each device like this will have a different clearance needed depending on which angle I am and how far I am from that device. So you will need to read the manual and talk to your safety manager about total clearance needed with this device. There is no set, for instance with this, 18.5 feet, there is no guaranteed distance. It could be anywhere from 5 inches up to 10, 12 feet, depending on how far away I am, how much swing I have. So you need to make sure you calculate that based on your distance. My inspection process with these, I'm checking all my metal components, making sure my carabiners, they're a twist and an open, make sure that's still functional. Snap hooks, thumb plunger plus anchor, make sure that doesn't stick. Making sure, again, all my tags are present. Making sure my pack is in good form. You'll notice there's a plastic sheath around these packs on the interior. That is there to keep dirt and stuff off. Do not remove that, leave that intact. Tags, again, present and legible. Keep this shroud on there to protect the device. Once I've inspected it, I also want to check my webbing. I want to deploy the entire length of this and make sure everything's good. I don't want to see any burns, cuts, stitches missing, things of that nature. And again, I can check it at different heights and make sure it locks up. Once I know my device is good, snap hook will go on my back. This will go up my anchor point connection, and I'm off to the races. All right, so we've got our anchor point connectors, body harness, everything's inspected, life is good. The next thing we're going to do, we're going to discuss fall protection as far as the different devices and why we do and don't use some of them. I have a 220-pound weight designed to simulate the average worker out in the workforce. The first drop we'll do is on a restraint lanyard. This restraint lanyard is designed just to restrain you from an edge or used for positioning. It is not designed for fall arrest, and you'll see why. During the lanyards, we talk about 6-foot fall clearance. What I'm going to do here, I only have this a foot in the air, so it's only going to be a 2-foot free fall, so you can see how much energy is actually created just in a 2-foot time frame. So 2-foot free fall, 220-pound weight, in 3, 2, 1. So you can see it's a lot of shock and a lot of force. That's anywhere from 3,000 to 5,000 pounds of energy generated into that worker. You'll also notice when it hit, it didn't stop, it whipped around. All that energy has to dissipate and go somewhere. So if you don't have an energy absorber in the system, you are the energy absorber in that system. The next drop we'll do is on a regular restraint lanyard. These are designed by OSHA regulations to get the arresting force under 1,800 pounds of energy. Most of your manufacturers follow what we call an ANSI, which is a different standard. they go to 900 pounds of maximum resting energy. Again, with about that same 2-foot free fall, this is a shock absorbing lanyard designed to get that arresting force under 900 pounds of force. 3, 2, 1. So you can see it was much smoother, and this is my area of deployment. Remember, we talked about in fall clearance. When you fall, you could have up to 3.5 feet of deployment. That is this area where I started to where I finish. It's important to know what that device is capable of so you can add that into your calculation. Now, all of this stuff is one and done. Obviously, now that I've fallen, you can see it's deployed. You'll cut this up, throw it out, never to be used again. The third drop we'll do is on a mini retractable, similar to what you use. Those are designed to have a quicker stop. I want to eliminate as much swing fall and as much dropping as I can. In an ideal situation, if I were to fall, I would be able to self-rescue. Obviously, if I were 4 or 5 feet above this and I fell, I've got quite a climb left ahead of me. With the small retractables, I'm able to set these up and have them stay in tension the entire time. Again, no matter if I'm a foot above it, 2 feet above it, it will lock up wherever I am in the event of that fall. As I work up and down that system, you can see it stays in tension. That helps reduce that swing radius and that swing fall. Once I'm into position and I do take a fall, 3, 2, 1. You can see it's very quick and very boring. That's what you want. You'll notice my free fall distance is pretty short. In this type of fall, I can most likely climb back to where I came from. You'll notice there's a red tag sticking out now. That's my fall indicator. There's still a shock pack here that can also absorb energy. But again, in these short free falls, it's very rare this thing will open up full length. It can. So again, when I calculate from where I'm tying off to where I'm going, I do need to include that in that calculation. But you can see how much energy is taken away in that short fall.